Okay, so in this problem we are going to be working on heat supplied or removed and the changing of temperature of a substance. So let's read the question. Can carry excess energy from the interior of the surface of the body where the energy is dispersed in a number of ways. While a person is exercising, zero point 0.3 kg of blood flows to the body's surface and releases, that's key right there, releases 2,000 joules of energy. The blood arriving at the surface has a temperature of the body's interior, 37 degrees Celsius. Assuming that the blood has the same specific heat capacity as water, determine the temperature of the blood that leaves the surface and returns to the interior. Okay, so let's start off with the equation that we use. So that will be Q, which is the heat either supplied or removed, is equal to C, which is the specific heat capacity, and we are given that from the book, and it says it is 4,186 joules per kg Celsius. And next it is the mass times the change in temperature. So what we're looking for here is the temperature of the blood when it leaves the surface. So what I'm going to do is break down the change in temperature. So what we'll have is it's going to be the temperature final minus the temperature initial. And what we're solving for is this temperature final here. So what we want to do is move it all around algebraically and then put in the numbers. So we are going to divide both sides by specific heat capacity and the mass, and then we are going to add over the initial temperature. So what it should look like is Q divided by specific heat, and then it's plus temperature initial is equal to the temperature final. Okay, so we can start plugging in some numbers here. So since we have the internal temperature of the blood is 37 degrees Celsius plus, so it is releasing 2,000 joules of energy. So you want to make sure that you put a minus sign there. So minus 2,000 joules divided by the specific heat, which in the question it says assume that blood has the same specific heat capacity as water, and that is given as 4,186. And we are going to times it by the mass of the blood flowing to the exterior of the body. And for your answer, you should get 35.4 degrees Celsius for the blood that is returning back to the interior of the body. Thanks. Hopefully that helped.